Hello everyone. In this video we will discuss two very interesting questions of PDA. Okay, so this video is going to be a little bit longer one, so if you watch this video till the end, then it would be very beneficial for you. So the questions we'll discuss today will be very interesting. Okay, so let's start with the first one. So we have to design a PDA for the language L is equal to a to the power n, b to the power m, c to the power m and d to the power n, where n is greater than equal to 1 and the value of m is also greater than equal to 1. So these values are actually independent of each other. That is, the value of n and m will not be equal, not necessarily equal. So what we can have in this one, that is, this a and this d should be equal and this b and this c should be equal. Okay, so what logic we can apply in this one is a very simple one, just a matter of 4 alphabets in this one, but it is very simple. Okay, so what logic we can have in this one? First of all, I'll tell you what kind of strings are there in this one. Okay, if we take the value of m is equal to 1 and n is equal to 1, okay, then in this case the string that I'll get will be a, b, c, d. Okay, so I have to design a PDA that should accept this kind of string. Or if I take the value of m is equal to 2, n is equal to also say 3. Okay, so in this case the string that I'll get will be n is equal to 3. So we'll get a and a. Then we have b is equal to, so we have 2 b's, and then again c, that is, we'll be again having 2 c's, and then d should be equal to a. So we'll be having 1, 2 and 3. Okay, so these kind of strings will be accepted by this PDA. So what logic we can have in this one? The simple logic is, when the first a comes, we will push it into the stack. So first a will be pushed, second a will be pushed, third a will be pushed, and then b comes, b also will be pushed, and again b comes, b also will be pushed. So now at this point we have 5 elements into the stack and b is on the top. Okay, and then 2 b's and then followed by 3 a's at the bottom of the stack. Okay, now this is till this point we have 5 elements. Now from this point to this point again we have 5 elements. So what I'll do, right now on the top of the stack we have b. Now c and b has to be compared, that is, c should be kept equal to b. So what we'll do, when the c comes, we will pop one b for this c, then again c comes, we will pop one more b. Okay, so these c's and b's are equal now. Then the top of the stack now becomes a. So d comes, I will pop this a, again d comes, pop one more a, again d comes, pop one more a. Okay, so we'll take this one and try to design a PDA for this one. Okay, so let's design it. Okay, so let's take our input tape first. Okay, I'll take input phase into input tape, and in this input tape I'll have the same string, that is AAA, double B, double C and triple D followed by epsilon. Okay, so we have this one. Fine. So what I'll do now, the pointer is currently on the first A and we have a stack here. In stack we have a Z0. Okay, so we'll start doing it. So what I am doing, we are pushing all the A's, we are pushing all the B's, then we are popping and we are popping again for the D's. Okay, so let's start. So it is the initial state Q0. Okay, and at Q0 we have to push the alphabet. So what first move we'll take, that is, the element to process is A and the top stack element is Z0, and what are we doing? We are actually pushing it. So I'll push it and this A will come here and the pointer will now move on to the second A. Okay, now second A again I'll take a move, that is, the element to process is A, the top stack element now becomes A and we will push it. So this A will also come in the stack and the pointer will move on to the next A. Okay, so next A again will be processed with this transition only. So next A will also be processed and this A will come here and again we have got this B. Okay, now what we'll do, we again have to push the B's also. So I'll take a move for B. The element to process is B, the top stack element is A, and what to do? We have to push it. Okay, so we'll push it and move on to some other state. Now again B comes, so I'll take a self loop here. I'll take a self loop, that is B, elementary process is B, the top stack element is again A, sorry not A, it will be B this time, okay, because this B has been pushed in and B is there. Okay, so elementary process is B, the top stack element is B, and what are we doing? We are pushing it. So we'll push it again, this B will be pushed in, and there are now 5 elements into the stack. Okay, so all the B's will be pushed in. So A's are pushed in, and then first B is pushed in, and then all the B's are pushed in, and the pointer will now come on to the first C. Now from this point onwards, we have to start popping the elements. Okay, so what element I'm getting right now? First of all, I'm getting C. So what I'll do, I'll take a move for C, that is the elementary process is C, the top stack element is B. Okay, and what we have to do? We have to pop. So we'll write epsilon and we reach on to state Q2. Okay, so what happened? For this C, this one B will be popped out. Okay, so one B is gone now, and the pointer will now move on to the next C. Okay, so we are again on the next C. So again, what we have to do? We have to pop all the C's. We have to pop all the B's. For all the C's, we are popping all the B's. So here again, I'll take a self loop because we can have several C's. So I'll take a self loop, that is the elementary process is C. The top stack element is again B, and what we have to do? We have to pop. So we will write epsilon, and this B will again be popped out, and the pointer will now move on to the next D. Okay, now next D, what we'll do? We'll again take one more transition, that is the elementary process is D, and the top stack element is now A, and what we have to do? We have to pop it out. So I'll pop it, I'll pop 1A, and we reach on to some other state, say Q3, and the pointer will now move on to the next D. Okay, now we have several D's here, so what I'll do? I'll take a self loop here, and here I'll write the elementary process is D, the top stack element is again A, and we are popping it. So all the A's will be popped with this transition, and this cursor, this pointer will now move on to epsilon. That means the string has been ended now. So from here I'll take a move for epsilon. So all the A's are pushed in, all the B's are pushed in, and then C comes, B's are popped out, D comes, A's are popped out. Okay, so we are done. So from here I'll take a move for epsilon, comma top stack element is Z0, and we are skipping it. We reach on to some state Q4, say it is a final, and we are done. Okay, so this is a PDA for the language L is equal to AN, BM, CM, DN. Okay, so I hope you understood this one. Fine. Now let's take another one, the next one. So we have to design a PDA for the language A to the power N, B to the power M, where the value of M and N is greater than equal to 1, and M is greater than N plus 2. Fine. That is, suppose we take the value of N is equal to 2. Okay, then the value of M will be, that is, it will be greater than 2 plus 2. So 2 plus 2 is 4, and greater than 4 is 5. So we'll get the value of M as 5. So it will be either 5 or 6 or 7 or 8 and so on. So any value, that is, we have 2 if N is equal to 2. So M will be 5 or 6 or 7 or 8 or 9. So anything like that. So for the minimum is, for this one string, suppose I take the value of N is equal to 1. That is the minimum in this case. So if N is equal to 1, then the M will be, that is, it will be greater than 1 plus 2, that is 1 plus 2 is 3, and greater than 3 is 4. So we'll get M is equal to 4 in this case. Okay, so it is minimum 4, and it can be 5 also, it can be 6 also, it can be 7 also, it can be 8 also, and so on. So we have to design a PDA for this particular string. Okay, so let's take a string in this case and then start doing it. So the string can be, suppose we have the string is equal to, say N is equal to 3. Okay, so if N is equal to 3, it will be A, correct? And then we have B. So B is greater than N plus 2. So 3 plus 2, 3 plus 2 is 5, and greater than 5 is 6. So we'll be having 6 B's here. So I'll have 1, 2, 3, 4, 5 and 6. So we have this one. Suppose this is the input tape again, and in this input tape followed by a epsilon, and we'll start with this one. So the pointer is currently on the first A, okay, and I'll make a stack here. In the stack, what we have Z0. Okay, so let's start doing it. So what is the logic in this one? The simple logic in this one, let's draw this side. We have Z0 here. So the simple logic in this one is, first A comes, we will push it. Second A comes, we'll push it. Third A comes, we'll push it. So all the 3 A's are now pushed in. Okay, so in stack what we have 3 elements now. Now the elements that we'll be having next will be having 6 B's. Okay, that is plus 3. Okay, so if we are having 4 A's, we'll be having 7 B's here. So that will be at least 7. Okay, at least plus 3, at least, I mean, it can be 4 also, 5 also, 6 also, anything can be there. So we have pushed 3 A's into the stack, and first B comes, what I'll do, I will skip this. Second B comes, I will skip it. So 2 B's are skipped. Third B comes, pop 1 A. Fourth B comes, pop 1 more A. Fifth B comes, pop 1 more A. And now the 6th one comes. 6th one can be bypassed. Why we are bypassing the 6th one? Because after this one we can have several B's. I can have. Okay, so I will complete my popping till the the first and the second one will be skipped, and then for 3 we will pop. Okay, if we have 4 here, we'll pop 4 here. If we have 5 here, we'll pop 5 here. Fine. So how many elements are there for A? We'll pop for B. Fine. So let's begin with this one. So first of all, the initial state is Q0 and the elementary process is A. So what are we doing? We are pushing it. So I'll take a move, that is A, elementary process is A. The top stack element is Z0 and we are pushing it. So we'll push it. A will come here and the pointer will move on to the next state. Next state again, I'll take a move for A, that is elementary process is A, the top stack element is A, and we are pushing it. So again this A will be pushed in and the pointer will now come on to this next one. This again transition will be used and again one A will be into the stack. So we have 3 A's into the stack now and the pointer is now on to the first B. Okay, correct? Now what we'll do, first B comes, we have to skip this B. First B and second B have to be skipped. Okay, so first B comes and the elementary process is B, the top stack element is A, and what we have to do, we have to skip it, that is let it be A only and reach on to some state, say Q1. Okay, so we are now at Q1 and the pointer will now move on to the next B. Now again this next B has to be skipped. Okay, so I'll again take a move for B, that is the elementary process is B, the top stack element is A, and let it be like as it is and we will skip it. The pointer will now move on to the next B. Okay, now these 3 B's, for these 3 B's we have to pop these 3 A's. Okay, so we'll reach on to some other state, say Q2, and now we have to pop 3 B's. Okay, so what I'll do, I'll take another move for popping the B, that is the elementary process is B and the top stack element is A, and what we have to do, we have to simply pop it out. So this one A will be popped and this pointer will now move on to the next B. Okay, now we have 2 B's to process. So what I'll do, I'll take a self loop here and elementary process is B, the top stack element is A, and pop out. Okay, so this transition will be used and all these 2 A's will be popped out and the pointer will now move on to this one and finally on to this one. Okay, so now the elementary process is B again and all the A's are now popped in. What is left in the stack? Z0 is left. Okay, so from here I'll take a move again for B only, that is the elementary process is B, the top stack element is Z0 and we are simply skipping it. So we'll write Z0 here only and then Q4, reach on to some state Q4, and this will be skipped. In this one we took only 3 B's more than A, but we can have 4 B's more than A, we can have 5 B's more than A, we can have 6 B's more than A. If I have some more B's here, so what I'll do, I'll simply bypass all those B's. So I'll simply take a self loop here, that is the element to process is B, the top stack element is again Z0, and what do? We just have to simply bypass it. Okay, now after bypassing all these B's, this pointer will now come on to the end of the string, that is the epsilon. Okay, so what I'll do, I'll simply take a move for epsilon, that is if the element to process is epsilon, the top stack element is again Z0, and we reach on to state say Q5, make it as final, and we are done. Thank you so much.